Hello everyone and welcome back to another tutorial. In today's video, we'll learn how to interface a sound sensor with Arduino using the Proteus simulation. This project will help you to understand how the sound or noise level can be detected electronically and displayed on the LCD in real time. We'll go step by step from the sensor introduction, circuit design, and coding explanation to testing the simulation. So let's begin. First of all, I would like to share the introduction of this sensor. The sound sensor is very handy device that detects the sound wave from the environment and convert them into electrical signals. It mainly consists of microphone, amplifier circuit, and the comparator. The microphone picks up the sound, the amplifier strengthens it, and the comparator convert it into the readable digital signal for the microcontroller. Mainly, you will see the sensor has four major pins. The first one is the analog output pin that gives the continuous voltage depending on the sound intensity. The second one is the digital output pin that changes the where the signals change from high to low or low to high depending on the threshold value. We also have a VCC for the power and the ground for the ground terminal. The simulation will help you to understand how microphone and sound sensors are used in the real-time applications such as noise detection system, automatic lighting based on the claps. You will also have seen the sound activated alarms. So for all these type of applications, you can use this sensor. So before building the circuit, make sure you have the necessary libraries installed in your Proteus setup because by default Proteus does not have these. So the first important library is sound detector. The second one is the Arduino library for the Proteus. And the third one is the new LCD library for the Proteus. I will provide the links of all of these into the description. Now, if once you have installed all these libraries, you are ready to create the circuit as I have created the one. This is our circuit. As I have mentioned that it has four pins. The analog pin requires this LC circuit to work naturally as you will get the output in the real time when you will create the circuit. So this LC circuit is important here. This voltmeter will provide you the information about the digital volts around this capacitor. So this output is now going to the analog pin of the microcontroller. This is the ground pin, this is the power pin, and this pin is connected to the digital output. This is the digital output, and I'm using the LED, green color LED, to show that digital signals are high or low. As you know that Proteus does not have any mechanism to insert the sound in it, therefore we are using the testing pin. A potentiometer is attached to it. So what will be going into the circuit? The user will provide the input from this potentiometer. Changing in its resistance will change the analog and the digital signals. These signals will be inserted into the Arduino. Arduino will convert these signals into the meaningful output, and that output will be displayed on the LCD. So this is the whole working, and to do all of this, we'll need to have the Arduino code. So I have created one. See here. Before using the LCD for any project, you will need the LCD library in Arduino. So make sure you have installed it. Once you have done, you can paste this code here. As you can see, this code is according to the simulation we have created. You have to first install the liquid crystal library. to get all the features of the LCD and use them in your code. After that, we have mentioned the LCD pinouts connected to the Arduino. These pin definitions are very critical as well. We are defining the analog and digital pins connected to the Arduino. This is the setup function that will be run only once. It will provide the introduction to your project. Uh, it provides the very professional way to start the project. So you can change the text in the quotation marks if you want so, but I don't think you should make any change in the code until you have understand it. So the main working has been done in the loop function. As you can see here, we are using the defined pin. See, these are the defined pins, and in the loop function, the Arduino continuously reads the function. So what is going on here? It is continuously reading the output from the analog and digital pins, getting it, and understanding if the signals are, if the digital value on the sensor is high, it will show on the LCD that the sound is detected, and if it is low, then obviously it will show the status that there is no sound. Similarly, it is also learning about the analog read values and displaying it on the LCD. So to make the connection between the code and your simulation, you have to do a simple step. You have to compile the code. It will automatically provide the hex file address. You have to search for it. As you can see, it has provided me this. You just have to copy this without any quotation mark. Let me do it for you. See. Okay. Copy it. Go to your simulation. Double click on the microcontroller and paste it here as I have pasted it before. Click OK. Now there is a connection between your simulation and the code, and you can play the circuit. This is the introduction as I have shown you in the code. Fine. Right now, we are at the zero resistance on our potentiometer. Fine. Zero resistance means the highest voltage. You can see this is the maximum voltage value. Our digital signal is high, and all this is shown on the LCD. It says that the analog value is the highest, digital signal is 1, that is also highest, and the status is sound is detected. If you want to change, so you have to increase the resistance. So after the threshold value, you can see that the digital pin is low, the voltage is the least because our resistance is the highest, and you can see that it says that analog values are 0, digital values are 0, and there is no sound around the sensor. I hope this project was helpful for you, and if you need any assistance or if you are stuck at any point, you can ask in the comment section.